with us Dr. Vinay Kumar sir, NIT Jamshedpur. Can I have your voice, sir, please?
Yeah, good morning, all of you.
Good morning, sir.
Okay, give me a 1 second, right?
Yes, sir.
इधर कोने में देखो थर्ड ऑप्शन आएगा इस कोने में
Right. Okay, is it visible, ma'am?
Yes, sir.
Can I
Sir,
start?
you can share your PPT, sir.
Okay, okay.
Dear participants, this is our session number 12 by Dr. Vinay Kumar sir, Assistant Professor, NIT Jamshedpur, and his topic is Federated Learning and its Application.
Yeah, good morning, all of you. In this session, ma'am, is it visible?
Yes, sir.
Yes, sir, it is visible, sir.
Okay. So in this session, I will give you a flavor of modern scalable data science paradigm, such as federated learning. As we all know, data science is a field which unifies data mining, statistics, and machine learning, and it obtains insights, decisions, and predictions from data, right? It has been observed that the more data we use for obtaining such insights and predictions, the better our predictions and insights become. Hence, data science on massive data is a very useful things to do. However, given the legacy computing infrastructure, it is not always possible to do so, right? For example, consider a switch have a very low amount of memory. Okay, if I want to uh, store the IP addresses which are passing, right? So now consider such problem when we wish to find the most frequently occurring IP addresses in the stream. It is not possible to store all the IP addresses which are passing through the switches, okay, which is a larger number, right? So the problem is to find the most frequently occurring IP addresses, even though we cannot store the frequency of all the IP addresses. We have another problem. Consider a situation that you have a collection of millions of images, some of which are duplicate of other images. A simple calculation will show that comparing every images to every other image will take years of time on current computing hardware, right? The question is, can we quickly find the near duplicate images approximately without comparing every images to every other image? The next problem, that is the third problem, is where we consider that we have a millions of data points, right? And each of these data points has billions of features, and we wish to classify these data points into different known classes, right? So how can we train or classify on such huge scale by utilizing, say, hundreds or thousands of servers in a distributed manner? These are some examples of problems which deals with scalable data science, particularly in the field of machine learning. Okay, uh, basically it deals with the latest high ML framework, that is the federated learning. Okay, this session will be a mix of both theory and practice. In practice part, my research scholar Mr. Adit Narayan will help me. So let us start from how data is precious. So there is a famous phrase attributed to Sir Tim Berners-Lee, the inventor of the World Wide Web, that goes, data is a precious thing and will last long than the system themselves, right? In another word, we can say that data is the new oil, is no more a marketing mantra but a reality. Data has a mandatory value or monetary value. So it's natural that many companies and individuals would want data and be able to monetize it. In the digital world, the value of data is revealed through the relevant insights it offers. Much of the competitive advantage depends on unlocking the intelligence it holds. That means effective decision making is a crucial to the success of any business or organization. Okay. Unfortunately, the opposite is also true. Failure to establish a culture that fosters effective evidence-based decision making can be crippling. Therefore, we can say data is the fuel of any statistical analysis as well as for decision making. So the amount of data generated by different systems become homologous with the rapid development of intelligent system, right? So the world technological per capita capacity to store information doubled every 40 months as of 2012, right? For example, it is a 2.5 exabyte of data per day. And you know very well that 1 exabyte is equivalent to 10 lakhs GB. So due to the large size of data, relational database management system and desktop statistics and visualization packages often have difficulty to handling such big data. So big data is a field that treats way to analyze, systematically extract information from or otherwise deals with data set that are too large or complex to be dealt with by traditional data processing applications. So big data is a field that treats way to that feels the where the new driver for digital economy and society will be driven by the machine learning. Okay, so according to Gardner, hundreds of billions of GDP is based on big data in 2021. So it is an intelligent factor after labor and capital. So what is the 5 V's of big data? In recent year, big data was defined by the 3 V's, but now there is 5 V's of big data, which also termed as characteristics of big data, which are as follows. The first one is the raw data. What is the raw data? It is in terms of volume. The name big data itself is related to a size which is enormous. Okay, so volume is a huge amount of data. To determine the value of data size of data plays a very crucial role. If the volume of data is very large, then it is actually considered as big data. This means whether a particular data can actually be considered as a big data or not, it is depends upon the volume of data. Hence, while dealing with big data, it is necessary to consider a characteristics volume. For example, in year 2016, the estimated global mobile traffic was 6.2 exabytes, right, per month. Also, by the year 2021, we have almost 40,000 exabyte of data. The second characteristic is the change over time, that is called velocity. So velocity refers to the high speed of accumulation of data, right? So in big data, velocity data flows in form of sources like you can consider machines, networks, social media, mobile phone, etc. Right? So there is a massive and continuous flow of data. This determines the potential of data, that how fast data is generated and processed to meet the demands, right? So sampling data can help in dealing with the issues like velocity. Traditional systems are not capable of performing analytics on data that is constantly in motion. Okay, so for example, you can consider there are more than 3 billion searches per day are made on Google. Also, Facebook users are increasing by 22% approx year by year. The third one is that called data type. That is the variety. So variety is basically the arrival of data from you can say new sources that are both inside and outside of an enterprise, right? So it can be structured, semi-structured, and unstructured. So before going to the further, we should understand what is the structured. So a structured data is the data type which is basically an organized data. It generally refers to data that has defined the length and format of data. For example, SQL data, right? So next one is the semi-structured data. So such data is basically a semi-organized data. It is generally a form of data that do not conform to the formal structure of data. For example, log files, XMLs are the examples of such type of data. The third one is the unstructured data. This type of data basically refers to unorganized data. It generally refers to a data that does not fit neatly into a traditional row and column structure of the relational database. Okay, for example, texts, pictures, videos are the such examples which cannot be stored in the form of rows and columns. Okay, the fourth one is the data quality, that is veracity. It refers to the you can consider inconsistencies and uncertainty in data, that is data which is available and can sometimes get messy, and quality and accuracy are difficult to control. That is the daily, sensational, and event triggered peak data loads can be challenging to manage, especially for unstructured data, right? So big data is also variable because of the multitude of data dimensions resulting from multiple disparate data type and sources. If you want to consider an example, then data in bulk could create confusion where less amount of data could convey half or incomplete information. Okay, another example you can consider that where large natural disaster would spike pages visit for any news channel. So last one is the information for decision making, that is called value. Okay, after having the 4 V's into account, there comes one more V which stands for value. The bulk of data having no value is of no good to the company unless you turn it into something useful, right? So you can say data in itself is of no use or importance, but it needs to be converted into something valuable to extract information. So you can state that value is the most important V of all 5 V's. So in big data is a real world example, right? In big data, we have a log storage in IT industries. When we are looking around the data center IT industries, it's difficult to ignore the potential in all of the big data available from infrastructure systems, right? So these industries store large amount of data as long as to deal with problems which occur rarely in order to solve them, right? So there are servers and application logs, data from networks and storage tabs, and metadata from database and application. Uh, in addition to the server and storage infrastructure, there is data from network devices, which includes security devices logs and routers and switch data. Okay, in theory, all of the data could be used to identify trends, to predict or even prevent service outage. At the very minimum, this data could be used to correlate events and identify source of application issue. So there are we have various type of tools such as the Splunk, VMware, and virtual infrastructure structures, which can be used for the data realization. So now we have a census data. Okay, with the emergence of the internal of things, okay, uh, and using wireless sensor networks, whenever we go for the Internet of Things, sensor devices are deployed across the globe in a variety of fields, right? Such as healthcare, industry, agriculture, home, and transport. So recently, Cisco estimated that there would be approximately 850 zettabytes, and we know 1 zettabyte is a 10 power 21 bytes of data generated from devices. Okay, so an IoT application may have hundreds or thousands of sensors, right, which produce vast amount of data, but the data is useless if we are unable to use it in decision making results. So in this figure, you can see an overview of data flow of typical IoT application, okay, where a physical sensor such as temperature or humidity sensors measure and collect readings in the perception layer. Okay, so perception layer is the physical layer which has sensors for sensing and you can say gathering information above the environment. So the readings are then transmitted through the network layer, which determines the routes to send the sensor data and is implemented using various wireless technology, such as you can consider Wi-Fi, 2G, 3G, 4G, whatever you want, Bluetooth, and long-range wireless technology. Okay. Next, the application layer receives data from the network layer, and it is where data processing, predictive analytics, and storage takes place, right? So the application layer is designed and implemented using big data architecture such as Apache, Hadoop, Spark, Kafka, etc. So what is the risk analysis in the big data? So utilization of big data has the potential to improve your organization risk management strategy. It allows you to adopt a predictive approach which increase the accuracy of threat detection. As a result, you will institute mitigation mechanism before the threat affect the normal operations of your organization, right? So you can say that a lot of potential data is underutilized because of its volume and should be integrated within the model to determine the risk patterns more accurately. So you can say there are the several ways where we can use big data to transform the security systems for an organization. So you can use, the first one is the prevention of fraud, right? Okay, so here we use the predictive analysis, which is an excellent way of detecting money laundering and other fraudulent activities, right? So the large volume of data is obtained from a different source, which guarantee close monitoring of activities in the different platform. Okay, so this can be increase the probability of detecting plans to engage in fraud before it happens. The second one is the management of risks associated with the third party. Here, if you decide to engage vendors in your business, right? So you should be careful since they can compromise the integrity of your security system. For example, or better to, it is advisable that you use big data analytics to manage the operational and reputational risk limited to their involvement in your business. Okay. The next one is the crucial in detecting churn rate for the organization. So loss of customer is painful for any organization. As such, we should use all the metrics to measure the probability of losing our clients to a competitor, right? So one of our surest techniques which involves the use of big data analysis, right? So when we monitor the behavior of any client, we can quickly understand or notice the discontentment and complaints which will directly influence our decision. So after that, we have a help in credit management. So credit is a high risk that has the potential to paralyze the operation of your business, right? So as such, it's paramount that you manage the risk by analyzing big data to determine the previous economic history of your organization, right? So this approach will, you can say that enable you to access the payment pattern, airtime purchase, and any other factors that may indicate possible loopholes of money misuse. Okay, then we have managing commercial loans. So you can say that before issuing any loan to a client, financial institution evaluate the ability of individual to repay, right? So to improve the accuracy of prediction, these institution can use a big data analytics to analyze the spending patterns of the potential customers. So the next use is the social media. So the big data phenomena applied to social media is fueling a new growing area of study known as sentiment analysis, right? So basically its aim is to be aware of what people say or share in their everyday life business, mine this information to understand their customers and to improve their operations accordingly, right? The way in which big data is impacting social media marketing, with the advent and increased use of internet, social media has become an integral part of people's daily routine, right? So social media is not only used to connect with others, but it has become an effective platform for businesses to reach their target audience. Okay, so with the emergence of big data, social media marketing has reached uh, in 2021 to accumulate the volume of big data of 44 trillion gigabyte. Okay, with such an enormous amount of data available, marketers are available to utilize it, right, to get actionable insights for framing efficient social media marketing strategies. Okay, for example, personalization. Okay, so big data enables personalization, allowing brands to approach their customers in a more personalized way based on their choice and likes. Okay, it also used in decision making. So big data allows marketers to identify social media trends and gain insights, right, which can be used to make engagement decisions, like which users to communicate with, which group of users should receives marketing email, etc. It also makes it easier to keep track of demographic to decide which social media platform to target. Then effectiveness of campaign So big data is also useful in tracking the performance of social media campaigns and finding out the gradual change in returns on investment. It also allows marketers to test their campaigns before launching it. Okay, analyze the results, make changes in its campaign as required, and reset it. Then we have a product insights. The social media marketers can effectively use big data to judge future buying patterns and trends. Big data increase the certainty regarding you can say what customer wants, when they want it, okay, and how they want it. This gives the business insight into what their new products should be like. So why scalable data science is in limelight using the machine learning? Okay. So the first one is the privacy and security. The most important issues with big data, which includes you can say conceptual, technical, as well as legal significance. The professional information of a person, when combined with external large data sets, leads to the inference of a new private fact about that person. So, big data used by law enforcement will increase the chance of certain tagged people to suffer from adverse consequences without the ability to fight back or even having knowledge that they are being discriminated against. Okay. Thereafter, we have a data access and sharing information. If data is to be used to make accurate decision in time, it becomes necessary that it should be available in accurate, complete, and timely manner. Then we have a storage and processing issue. So many companies are struggling to store the large amount of data they are producing. Outsourcing storage to the cloud may seems like a option, but long upload time and constant updates to the data preclude this option, right? So processing a large amount of data also takes a lots of time. So you can say that we use the help of machine learning to find out the such insights. So machine learning is a method of data analysis that automates analytical model building. Okay, it is a branch of artificial intelligence based on idea that system can learn from data and identify patterns and make decision with minimal human intervention. So machine learning algorithm implementation and decision making become tougher day by day. So machine learning is a wise stage who gives human-like decision. Okay, so currently industry trends towards automation. Okay, therefore the role of this stage is crucial. But the no free lunch theorem of Walport argues that without having substantive information about the modeling problem, there is no single model that will always do better than any other models, right? So because of this, a strong case can be made to try a wide variety of techniques, then determine which model to focus on. So there is no global machine learning problem which can be a global solution. So the decision of the efficient ML algorithm is very complex. So life cycle of machine learning in data science. So machine learning basically automates the process of data analysis and makes data informed prediction in real time without any human intervention. A data model is, you can say, built automatically and it further trained to make real time prediction, right? So this is where the machine learning algorithms are used in the data science life cycle. The first one is the data collection. So collecting data is considered the foundation step of machine learning. collecting relevant and reliable data becomes very important, right? As the quality and extent of data directly impact the outcome of your machine learning model. Next one is the preparation. So data cleaning is the first step in the overall data preparation process. Okay, so this is an essential step in making the data analysis ready. Data preparation, it ensures that data set is free from erroneous or corrupt data points, right? So it also involves standardizing the data into a single format. Okay, so data set is also split into two parts to be used for training your data model and evaluating the performance of trained model respectively. Next, we have a training model. As you all aware that this is where the learning starts, right? So the training data set is used to predict the output value. This output is bound to diverge from the desired value in the first iteration, but practice makes a machine perfect. The step is repeated again after making some adjustment in the initialization, and the training data is used to incrementally improve the prediction accuracy of your model, right? Then we have a model evaluation where we have a uh, once we have done our training model, it's times to evaluate its performance, right? So the evaluation process makes user of the data set that was set aside in the data pre-processing process. Okay, so this data has never been used for training the model. So testing your data model against a new data set will give you an idea of how your model is going to perform in any real life application. So next one is the prediction. Now that your model is trained and evaluated, right? So it does not mean that it's perfect and ready to be deployed. The model is further improved by tuning the parameters, right? So prediction is the final step of machine learning. This is the step where your data model is deployed and the machine makes use of learning to answer you. So after that, we will go to the characteristics of the machine learning and its challenges. Okay. So ML is concerned with fetching valuable information from raw data. So the quantity of data is the primarily concern. If we are looking for historical data and the quantity is huge, then there is a challenge comes as a storage and retrieval of the same. Okay, if the data is stream data, then the model updation is a true challenge, as there may be information drift during the several round of the ML algorithm, right? So information drift is a change of the distribution of the current data stream. It occurs due to the uncertainty of data sources. Next, we have also identified the time to trigger for model training is a hard task. Okay, so batch processing may be a fruitful solution, but how the batch should be considered from the data queue is a quite challenge. Also, the huge dimension of the big data makes the model training painful, as we need to consider all the independent parameters. So now we consider the storage and retrieval of the large data. In the case, there are the several problems. The first is the storage around multiple number of servers. You can say that make the model training very complex, as the access of data is costly. If the data is vertically splitted, then we need to access the servers at once. Okay, it is more challenging. Next is the network bandwidth are more consumed during the training as excess of data is required, and they are distributed over network. Okay. Also, making the model training process fault tolerant is quite challenging, as maintaining the redundancy is a very hard in this case. Also, there are some privacy and security concerns regarding the access of data over networks. Then we have our key goals and features of design. So, efficient communication, asynchronous communication model. Most promising communication can be established as asynchronous, right? So, it helps the access of the data faster through non-blocking IO mechanism, right? So reactive spring in Java with Netflix, OSS stack, Akka and plain Scala Vertex for polyglot programmers can be considered for the API design at data storage site. Also, RESTful API design is more efficient in developing the ML model due to their uh, proactive response, right? Also, there is a chance of unwanted theft or loss of the data due to different attack like man in middle attack, apps dropping, etc. Okay, during message passing. So it may hamper the communication. Therefore, a proper encryption mechanism is mandated. So flexible consistency model is the next key goals. Okay, where algorithm designers should balance algorithmic convergence considering system efficiently. Okay, right. Here the designer must be aware of the system processing power, memory, consumption, etc. at the time of design phase. Okay, thereafter we have elastic scalability. So new nodes can be added without restarting the framework. Okay, it will maintain the consistency in user accessibility. Virtualization along with reactive programming in service oriented architecture, mainly different cloud architecture can be a good help. Okay, we can also call it ML as a service. Thereafter, we have a fault tolerance and durability. So redundancy can be a good solution to achieve fault tolerance. Also, system must be online within a few seconds if it goes down to minimize the loss of stakeholder. Right. Also, the ML model must be durable, which means it should not be updated frequently. In this case, we need to consider the information drift in the data during the execution. After that, we have a ease of use. So user must access the algorithm very easily and conveniently. Also, there should be a proper abstraction to the data storage and access to the user. Otherwise, the user can feel uncomfortable to use the ML to get decision and do errors. So here we consider the federated architecture. How is it possible to allow multiple data owners to collaboratively train and use a shared prediction model while keeping all the local training data private, right? So traditional mechanism or machine learning approaches needs to combine all data at one location, typically a data center, you can say, which may be very well volatile. The law on user privacy and data confidentiality, right? So today, many parts of the world demand that technology companies treat user data carefully according to user privacy law. Right, the European Union's General Data Protection Regulatory GDPR is a prime example. So, federated architecture has emerged as one of the most commonly accepted patterns of enterprise architecture built on the principle of interoperability, but does not really mean, okay, the term federated in generally sense in terms of a group of semi-autonomous entities exchanging information with each other, right? So a real world example of This would be looking at different states of a country which are managed by the state government. They are partially self-governing and exercise power to keep things running smoothly, right? So, and then these state governments share information with each other, and the central government making a complete autonomous government. This is just an example. So, what are the compliances in the federated architecture? Two example of interoperability that we can borrow from this government analogy are commerce and identity. The first example comes from all states accepting the same currency, like currency in a federated architecture system. There are some concept that every semi-autonomous system adopts. Okay, so identity is a different story. Each state has a verifiable unique ID card. Unlike currency, this is not uniform, but is often tied to a federally backed identifiers like a social security numbers. So what are the benefits of the federated architecture? One of the most popular stated benefits of choosing a federated architecture is allowing independent systems, teams, organizations, or entities to solve problem independently. Okay, the different kinds of you can say that independence includes life cycles, operational, and platform. Okay, so as mentioned previously, multiple regions make the problem of data silos. A data silos is a collection of data held by one group that is not easily or fully accessible by the other groups in the same organization. Okay, so it becomes impediment to the big data needed to train ML models. So natural to seek solution to build ML models that do not rely on collecting all data to a centralized storage where model training can happen. So an idea is to train a model at each location where a data source resides, and then let the sites communicate their respective model in order to reach a consensus for a global model. In order to ensure user privacy and data confidentiality, the communication process is carefully engineered so that no site can second guess the private data of any other site, right? At the same time, the model is built as if the data source were combined. So this is idea behind federated machine learning or federated learning for short. So federated learning system primarily focus on distributed systems in order to achieve higher accuracy with lower latency, maintaining privacy and data security with the availability of distributed data, right? So when we comes into the hardware part, the hardware computation is limited as the development towards semiconductor devices has already reached the ACME advancement. Okay, in order to process large amount of the distributed data generated by the several independent agents, current trends depends on the distributed system. Therefore, the challenges in designing a new distributed system are not only data privacy but also synchronization of independent components. Okay, so the federated learning approach centers the same goals. It trains the global model with the collected experience of the independent agents without sharing the actual data. Okay, it keeps the data security intact and also lowers the response latency and the given higher accuracy. So you can consider the right side figure. Okay, a general distributed machine learning approach is discussed. Here, locally computed results are shared among the parties in an encrypted form, right? The encryption is done through a public key, which is shared to a trusted collaborator, and the computed model are shared to the collaborator, then with which it will ensemble the model and update to a local parties, right? So here again, a biased and compromised model can be generated in the collaborator due to the availability of model to each of the local party. So federated architecture solve this problem. So, what are the federated learning application? So federated learning plus other ML algorithm, we can use federated learning in field of computer vision, in recommender system, in natural language processing, speech recognition, and next combination is federated learning with industry. So we can use the federated learning in fintech. Okay, so here, healthcare, then education, IoT, communication. So fintech, you all very well know. Fintech is a amalgamation in terms of finance and technology, and it refers to any businesses that use technology to enhance or automate financial service and processes. Right. Next, we have a types of federated learning. So distribution characteristics of data, that is the differentiating and the coding factor across heterogeneous data and client participating in FL, that is federated learning, can be broadly categorized as horizontal, vertical, and transfer learning. What are those? In horizontal federated learning, it is defined as the circumstances where dataset on the device share the same features with different instances, right? The classical release of federated learning from Google falls under this category. Then we have a vertical federated learning, is a federated learning approach where the common data between unrelated domain is used to train the global ML model, right? So participant using this approach prefer to have an intermediate third party organization or resources to provide encryption logic to ensure that the only common data sets are shared. Okay. One example you may consider that client A, for time being consider it as Amazon, has information about the customer's movie purchase on Amazon, right? And client B, you can consider IMDb, has information about the customer's movie reviews. Okay, using these two set of data set from different domains allows one to serve the customers better using movies review information, IMDb, to provide better movie recommendation to the customers browsing movie in Amazon, right? Next, we have a federated transfer learning. It is an implementation of existing classical ML transfer learning technique, which is a way to train a new requirement on a pre-trained model that is already trained on a similar data set for solving a completely different problem, right? So in the ML world, training on a pre-trained model gives much better results in comparison to training done on fresh model built from scratch. So one such example of federated transfer learning is to train a personalized model, example movie recommendation for the user's past browsing behavior. So we have moved to the taxonomy of federated learning system. The first one is the data partitioning. Okay, based on how data are distributed over the sample and feature spaces, FLs can be typically categorized in horizontal, vertical, and hybrid FLs, right? So in horizontal FLs, the data set of different parties have the same feature space, but little intersection on the sample space, right? So this is the natural data partitioning, especially for the cross device settings, where different users try to improve their model based on the performance on the same task using federated learning. Okay, in vertical federated learning, the data set of different parties have the same or similar sample space, but differ in the feature space. Many other applications, while existing federated learning mostly focus on one kind of partition. The partition of data among the parties may be hybrid of horizontal partition and vertical partition. Let us take a cancer diagnosis system as an example. A group of hospitals wants to build an federated learning for cancer diagnosis, but each hospital has different patients as well as different kinds of medical examination result. Okay, so transfer learning is a possible solution for such scenario. Then we have a machine learning models. So since federated learning used to solve machine learning problems, the party usually wants to train a state-of-the-art machine learning model on a specified task, right? So there have been many efforts in developing new models or reinventing current models to the federated settings. Okay, the most popular machine learning models now is neural network. Okay, so which achieves state of the art results in many tasks, such as you can consider image classification and word prediction. Okay, there is another widely used model in decision tree, that is the decision tree. Okay, which is highly efficient to train and easy to interpret compared with neural network. Okay, it is a tree based federated learning, basically designed for the single or for the federated learning of single or multiple decision tree. Okay, beside neural networks and trees, we have a linear models like linear regression, logistic regression, SBM are classical and easy to use model. Then we have a privacy mechanism. Although the local data are not exposed to federated learning, okay, the exchange model parameters may still leak sensitive information about the data. Okay, so there have been many attacks against the machine learning model. Okay, so differential privacy guarantee that one single record does not influence much on the output of a function. Many studies adopt differential privacy for data privacy protection to ensure the parties cannot know whether an individual record participated in the learning or not. Okay, so we have a communication architecture. So there are two major ways of communication in federated learning. First one is the centralized design and the decentralized design. Okay, so in the centralized design, the data flow is often a symmetric, which means the manager aggregates the information, for example, local models from parties and send back training results, right? Whereas centralized design is widely used in existing studies. Decentralized design is preferred at where the some aspects concentrating information on one server may bring potential risk or unfairness. Okay, we have a scale of federation. So basically, federated learning can be categorized into two typical types of a scale of federation: cross silo and cross device. In cross silo, the parties are organizations or data centers. There are usually relatively small number of parties, and each of them has a relatively large amount of data as well as computational power. Whereas in cross device federated learning, it is on contrary, the number of parties is relatively large, and each party has a relatively small amount of data as well as computational power. Okay, the parties are usually mobile devices. So motivation of federated learning or federation, motivation of the federation in real world application, federated learning, individual parties needs to motivation to the involved in the federated learnings. Okay, the motivation can be regulation or incentive. Federated learning inside a company or organization is usually motivated by the regulation. However, parties that choose to participate in federated learning can benefit from it. For example, higher model accuracy. So now I invite to Mr. Adit Narayan for the practical session. Okay, Adit, please come.
Uh, Good morning, everyone. Am I audible? Okay. Uh, so, so we'll start from the. We will have the basic assumptions about federated learning. There are four assumptions that we will have right now. Okay. So the first one, that is there should be multiple parties. Okay, and multiple parties will each of them will have some data. Okay, and that data is private to them, and they are eager to collaboratively join uh, in a in a training program. So this is the first assumptions. The second assumption is during training, no data share will be happening. Okay, there will be no sharing. Okay, so the next assumption is for the purpose of the training of the particular model, information the required information should be shared among the model. So there may be a question arises that if we did not share the data, how which informations will be sufficient to train a model in the iterations. So we will look into these things in the latter one, and that information we need to share some informations from each of the parties. So that information should be encrypted, and that's encrypted and protected. Okay, this is the third assumptions, and fourth assumption is the resulting performance should be good enough. Then the uh, single model. The single models means suppose we are using some standalone models. Okay, suppose we are using a CNN models. Now, if our federated CNN is giving better results, then it is acceptable because it requires a lot of information sharing. A new constraint has come to the circumstances that the information sharing is required. So performance of the resulting model should be very good enough. Okay. So these four assumptions are basic assumptions for federated learning. Let's see how a federated learning works. So this is a vertical, you can say vertical architecture. We have seen that there are three types of federated learning architectures: horizontal, vertical, and transfer learning. Sorry, this is a horizontal federated learning architecture where we have some components. What are the components? The first one is the federated controller here. You can look here, you can get assumptions that this is a centralized architecture. Okay, this is the federated controller here, and there are some models. There are some local models. Okay, so this is a schematic diagram, so we will understand how this federated learning works from here. Okay, so this federated learning controller is known as the server also. Okay, and they are the clients here also. So this is a centralized client server architecture. Okay, now every local model will have different data sets, as they will act as a party here. And fast of the iterations, what will happen at fast of the iterations, this federated controller will initiate a global model. All of them will have some models. Okay, all of them will have some models. So this will have a global model here. Then that model will be pushed into the local model at first. Okay, So FL controller will push to the local model, the local party, the global model that is initiated at the first iterations. Okay, and the data that is available on each of the parties will be used to train that global model in each of the machines, each of the local machines or local parties. Okay, and you will get some updated model here. Similarly, you will get some updated model here, here, and here. Okay, and that updated model will be pushed to the local controller to update its global component. To update its global component, a global model. Okay, so how this is updating? We are pushing, we are actually we are sharing our models, means we are sharing the parameters of the model. Okay, so that we will have that updated parameters here, and we will just weighted average about them. So how do we weighted average them? We will send two things. First one is the updated parameters, and second one is the number of data that is used to train the particular local model here. Suppose you are having a kth party. Suppose this is the kth party. Okay, so nk is the number of data that is used to train the global model here. Okay, that will be sent, and that parameters respective to the particular kth party, that's the wk, that is pushed to the FL controller. Okay, and here we are weightedly average them. N is nothing but the total number of data in the all local parties. So you will just sum all of them, you will get N. So by this way, we are averaging them. This is called federated averaging architecture. Okay, so this is the way our overall FL control federated learning works. Okay, so you can have a good look that here are some components that I have already told about you. That is, the first one is the FL controller and is the local model. And in as a model, you are required to have some machine learning models. So we can use their MLP as a neural. If we want to choose neural networks, we can choose MLP, we can choose CNN, we can choose RNN, anything. Okay, and if you want to choose any ML models, we can choose also any regression models, any that type of any machine learning models as well as. Okay, and we will just update their parameters. Okay, so second thing that is that is a key concern here, that is the communications, because you can see that there are a lot of message passes among the local model and the local party and the FL controller. Okay, so a communication should be optimized, because otherwise it will cause some delay. Okay, so how can we optimize them? We can consider that in here, suppose you have a large number of local parties, a lot of parties are there. Sometimes what you can do, you can consider sum of the parties. Means if the number of parties are small enough, then you can consider for full participation, means you can consider all parties. But if it is a high number of there is high number of parties, then you can consider partial participations, means you can select some parties. So how could you select these things? You can either have a predefined list, or you can uh, identify them on the way. Okay, so Okay, so you need to have some pre-processed list, either otherwise you need to select them on the way. So these are the some optimization process. Okay. Now the next one is the learning algorithm. What we will consider for our updating the parameters. The first one that comes into the picture, that is the federated SGD model. Okay. Um, the first one is the federated SGD model. Here, we will use SGD. SGD means stochastic gradient descent algorithm. Okay, stochastic gradient descent algorithm with federated settings means we will do update of our SGD parameters using federated setting. Okay, here the second one, that is the federated averaging perspective. Federated averaging perspective will do updates of the weights of the particular model, or weights or parameters of the particular models, not of the SGD. Here, for a federated SGD, your federated setting is used within the SGD architecture. Federated averaging always considers about the parameters of the particular uh, model. Okay, so it will much better. It will show much better results in terms of giving results in a faster manner, always rather than a federated SGD, due to considering the weights as the weights or parameters as they define the particular landscape of the particular neural network architecture that is being used. Okay, and another approach, that is FedProx, that is actually federated averaging, same thing with some proximal term that is used to uh, uh, add with the weights. Okay, so these three are the basic algorithms that has been used in federated averaging. Much more researches are there in updating those parameters. Okay, and the last component that is very much important, that is the one of the important aspects, that is the security and privacy of the federated learning approaches. As you can you can understand that this is a distributed architecture. Okay, yeah, so in distributed architectures, data sharing is information sharing is a very important key role. So to secure those informations, you need to have some encryption mechanisms. So homomorphic encryptions, differential privacy, secure multi-party communications, these type of policies can be considered here. Okay, so this is the challenges that we can have these things, we can have expensive communications here. As we know that there are a lot of communications between the multi parties, so there will be a lot of communications among them. Privacy is very big concerns, as there are cross silo or cross device communications, and as network is no network is 100% secure, so there will be a chance of breaching about the security. And also system heterogeneity. If we consider vertical federated learning, then we can have that concept that there are a lot of different type of data. Okay, like here in suppose this is a medical diagnostic system. Suppose you consider if like this, there are a lot of components, like different components. Some biomedical components like ECG, some are from EEG, some are from lab data, some are from your observations. These data should be club together to have a better models. So there are a lot of different systems involved in the federated learning. So this is a handling this type of constraint is very much challenging. Also, if you consider there are some statistical heterogeneity, because all of we can these all parties will have some data, and that data comes from some particular distributions, and that distributions can be changed in real world scenario. Okay, so there will be some drift in the information. There will be some drift in the information that can cause our model to be failure prone. Okay, so these are the challenges. Let's go to some let's see some practical aspects of it. um, okay, let's see something. Let's see how to implement these things. So this is a basically horizontal federated learning approach. Okay, implemented in TensorFlow. So actually, the Keras actually. The concept is this is very naive concept, naive type of simulation of federated learning. Okay, so here we have used MNIST data to do the simulations. Okay, so what we have done, we have just pre-processed them properly, and we have trained for 10 rounds. You can understand that federated learning is a iterative process. Okay, and that iteration goes for some rounds. Some rounds means they will train the particular global model for that particular number of times. That is called round, communication rounds. So that is 10 here. Our learning rate we have considered as 0.01, as we have considered MLP here, basic MLP. How do we implement that thing? That thing is implemented here, SGD. If we can see here, this is the particular helping code here. This is the MLP part that we have already implemented. Very basic MLP. Okay. So we have implemented that thing, and here we have implemented these things, and this is the architecture here. Now we are just training for all the rounds. Just look at these things. At first, we have initialized some global weights. Okay. At first, initialize our global weights. Then we have initialized something that is the scaled local weight list. That is the list of the scaled local weight. Okay, this will have all the local weights of the particular clients. So this is the client side part. Actually, we have not implemented every clients here. We have just done the simulations. That's why we are tracking it in a list. Okay, and we are putting those global weights, okay, into the particular local model. Okay, we have just initialized it, and we have just put that global weights here. Okay, and after that, for each of the client, we have feed that particular data that is available to the local models, and we have just feed the data to the local model. Okay, then we have calculated the scaling factor of particular local model. Okay, so this scaling factor is the scaling factor is calculated here. Okay, this is nothing but that this part, this calculation. Okay, nk divided by n wk. That is the part that we have calculated here. Okay. Simple thing. We have added them and we are just dividing them by global count. Okay. After that, we have we have scaled those weight. Okay. So this is the weight at first. This is the scaling factor that we are calculating. Then we are scaling those particular local weights. This means this is the nk divided by n, and we are scaling our local model by this scaling factor. Okay, and we are appending them to our scaled weight list. Okay, so this is happening for every clients. So how many clients we have decided to do these things? Here you can see this is okay. So this is the communication rounds we have considered for five actually number of clients. Okay. Uh, So this is happening, and after that we are averaging using those sum scaled weight. Here, what is happening? As this is tracking all the weights of the particular clients, so we are just adding them. We are doing the same operations here. We are just summing them. Okay, so this after that this average weights is set to the global model, and that loop is again going on. Okay, so we are getting the global weights from here again, and this loop is going on for 10 times, as our communication round is 10 here. Okay, and after that what have we are calculating the global accuracy and global loss, and we are doing so. Okay, so whenever we are running these things, these are the 5 clients data. Okay, and this is the global accuracy data. This is the accuracy, this is the loss. Okay, so this is happening for 10 times, and for each times you are having 5 client data. Okay, so this is the end of our particular practical sessions. Do you have any questions? Any questions?
Hello everyone. If you have any doubts, you can ask to the sir. Participants, if you have any doubts, you can ask to the sir.
Okay, then I think that should be in end of the session from our end.
Yes, sir. Sure, sir.
Okay.
Participants, the feedback link and the quiz link has been shared in the Google Meet chat box. Please go through and submit your feedback.
लेफ्ट करना होगा तभी नहीं दिखा उसको देखते हैं
शायद
देखो तो विनय जय 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 जय
Participants, the link will be active for the next 20 minutes. Please submit your feedback and do quiz session also.